Backpropagation is a fundamental algorithm in the field of artificial neural networks that is used to train models to make accurate predictions or decisions. At its core, backpropagation is a mathematical technique that allows neural networks to learn from their mistakes and adjust their parameters, or weights, to improve their accuracy over time. In a neural network, nodes, also known as neurons, are interconnected with weighted connections that transmit signals from one layer to the next. The weights determine the strength of the connection between nodes and are adjusted during the backpropagation process to minimize the error between the network's predicted output and the actual output. Backpropagation is important because it allows neural networks to learn from large datasets and make accurate predictions on new, unseen data. It enables neural networks to improve their accuracy over time by adjusting their parameters based on the errors they make during training. The first step in backpropagation is the forward pass, where the input to data is fed into the neural network. Each node applies an activation function to the weighted sum of its inputs, which is then passed on to the next layer. This process is repeated until the output prediction is calculated. Next, the error calculation, in which the error between the predicted output and the actual output is calculated, giving us the loss function. Step 3 is the backward pass. The error is propagated back through the network, starting from the output layer and working its way back to the input layer. The goal of the backward pass is to adjust the weights of the connections between nodes to minimize the error. Step 4 is the gradient calculation. At each node, the gradient of the error with respect to the node's output is calculated. This gradient represents the direction and magnitude of the change that is needed to minimize the error. This is done using the chain rule of calculus, which allows us to compute the gradient of the error with respect to each weight in the network. The next step is to use the gradients calculated in the previous step. The weights of the connections between nodes are updated in the direction that minimizes the error. This update is done using a learning rate, which controls the size of the update. Finally, steps 1 to 5 are repeated for each input in the dataset, until the error is minimized to an acceptable level. Backpropagation is a powerful algorithm that can be used to train various types of neural networks for different machine learning problems. For instance, a single-layer perceptron, which is a neural network that consists of only one layer of nodes with no hidden layers, can be used for binary classification problems. During training, backpropagation is used to adjust the weights of the connections between the input layer and the output layer in order to minimize the error. The algorithm updates the weights in the direction that minimizes the error, using the gradient of the error with respect to each weight. Once the weights are adjusted, the perceptron can be used to predict the class of new, unseen data. Another example is a multi-layer perceptron, which is a neural network that consists of multiple layers of nodes, including one or more hidden layers. This type of neural network can be used for various machine learning problems, such as classification, regression, and even image recognition. During training, backpropagation is used to adjust the weights of the connections between the nodes in order to minimize the error. The algorithm updates the weights in the direction that minimizes the error, using the gradient of the error with respect to each weight. Backpropagation is used to propagate the error backwards through the network, from the output layer to the input layer, allowing the weights to be adjusted at each node. Once the weights are adjusted, the multi-layer perceptron can be used to make accurate predictions on new, unseen data. One of the main advantages of backpropagation is that it allows neural networks to learn from data and make accurate predictions on new, unseen data. This makes backpropagation a powerful tool for a wide range of machine learning applications, including image recognition and speech recognition. Backpropagation can also be used to train neural networks with multiple layers, allowing for more complex and sophisticated models that can capture complex patterns and relationships in data. Additionally, backpropagation is computationally efficient and can be implemented on a variety of hardware, making it a practical and accessible tool for machine learning practitioners. While offering many benefits, also has some disadvantages that should be considered. One major issue that can arise when using backpropagation is the problem of gradient vanishing and exploding. This occurs when the gradients become very small or very large, which can prevent the algorithm from making meaningful updates to the weights. This can be particularly problematic when training deep neural networks, as the gradients can become increasingly small as they propagate through each layer. Another challenge that can arise is the need for large amounts of training data. Backpropagation requires a large amount of training data in order to learn accurate models, which can be difficult to obtain in some applications. Additionally, backpropagation can be computationally expensive, particularly when working with large datasets or complex models. I hope you have enjoyed this video, and thank you for watching. If you have any questions or comments about this video, please feel free to leave them in the comments section below. And don't forget to subscribe to our channel for more informative videos on machine learning and related topics. Thanks again, and we look forward to seeing you in our next video.